All right, so sample mean, remember, is X bar. Population mean is mu. So for a probability distribution, to find the mean, you are going to take the individual X values, multiply it by its probability, and then add them all together. Okay? You do not have to have this formula memorized, but you need to understand what it is, because chances are just looking at the formula isn't going to be enough if you haven't been practicing it. Okay? So, and whenever you see the sigma, uppercase sigma, that's the sum. So this is saying the sum of X times its probability. So that's the formula that you'll be given on your formula sheet. So find the mean of the number of spots that appear when a die is rolled. So what are my possible outcomes for that? You roll a dice. What are my outcomes? 1 through 6. 1, 2, 3, 4, 5, 6. What's the probability of each one? We're saying that it's not a loaded dice, so therefore they are all equal. It's fair. So everything is 1/6. So to find the mean, mu, you're going to do 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6, etc. I ran out of room. Hold on. Start over. So plug that in your calculator. All right, example 2. Go ahead and do that one on your own. Real quick. So a very old water system in a manufacturing plant has 4 independent valves that have a 50% chance of working correctly over a year. The valves are checked yearly to make sure the valve is either bad or good. So find the mean number of good valves. So the total outcomes is what? So we have 4 valves, and each valve can be good or bad. So what's my total outcomes? How do I find that number? 2 times 2 times 2 times 2, right? So 2 to the 4th. So I have the option of having 0 good valves, 1, 2, 3, or 4 good valves, right? Anywhere from 0 to 4. This is a combination. So you'll use your calculator to find 4C0, 4C1, etc. So go ahead, use your calculator and find that for each 0 through 4 values. Once you have your values, go find your probabilities. I don't care if you write it as decimal or fraction. It does need to be an exact one for this. So it might be best just to put it as a simplified fraction. Then once you have your probabilities, go find your mean.
So do you leave out the
Ah,
zero?
nope, I messed up. Thank you. All right, what did you get for your mean? 2. Questions on that? So you need to be able to look at a probability distribution and find the mean, and that's how you do it. Okay? If you can't do mean, you're not going to be able to do standard deviation and variance because they're using the mean. Remember, just for, we'll talk about it more later, but just a reminder of your population standard deviation formula. So remember, it was we take all the x's, subtract the mean, square that, add them up, then divide by the total number for population. Again, I'm not going to ask you to do that by hand anymore. You'll have a calculator for that. So either the standard deviation will be given to you or you'll be given the data and you can use stat edit and use a one variable statistic in the calculator. Okay? I'm not asking you to do that by hand anymore, just the chapter that we did it in. All right, so that's normal standard deviation. For a probability distribution, it is a little different. So to find mean, you take the x, multiply by the probability, and then add up all those values. To find the variance, so remember variance is squared, then take the square root to find standard deviation. To find the variance, you're going to square the x value, multiply by the probability, add all those up, and then subtract the mean and the value of the mean squared. Yep. So, and I think once you've done it a few times, you're going to see it's really easy. It's very similar to finding the mean. The mean is value times probability, add them up. Variance is value squared times probability, add it all up, subtract the mean squared. Okay? And then once you have variance, how do you find standard deviation? Take the square root. Okay? So, let's go to example 3. So, compute the variance and standard deviation for the probability distribution in example 1. So, example 1, we found the mean to be 3.5. So, example 1 was the dice problem. So, 1 through 6, and all the probabilities are 1/6. So, in order to find sigma squared, it's 1 squared times 1/6 plus 2 squared times 1/6. Hold on, I'm going to have to write smaller. Plus 3 squared times 1/6, etc. And then once you've done that, you subtract your mean squared. So plug that in the calculator. Remember, when you find variance, round it 3 decimal places to write on your paper, but do not round it when you're finding standard deviation. So when you do the square root, use your answer or go pull wherever that answer is so that it uses all the decimal places so that you're not rounding and cutting it off because it can change your answer. What did you get for your standard deviation, or sorry, for your variance? Say it louder. 2.917. And for standard deviation? 1.708. So first thing I'm going to do is create my table of values. I have X, I have the frequency, and then I have the probability. By the way, if you're doing this on a quiz or test, if you skip the frequency row and just use X and P of X, that's okay. I don't care. So I have X is 3, 4, and 5. So my frequencies are 2, 1, and 2. I have a total of 5. So my probabilities are 2/5, 1/5, and 2/5. So that's the first thing I got to do. Find my probabilities. Now I'm going to go find the mean. 3 times 2/5 plus 4 times 1/5 plus 5 times 2/5. And you should get 4. Yes? Okay. To find variance, it's very similar to mu, but instead of the values out in front being normal, you're going to square them. So 3 squared times 2/5 plus 4 squared times 1/5 plus 5 squared times 2/5. Oh, sorry, minus 4 squared. Yep. Bless you. So my variance is 0.8. Square root of that for standard deviation, 0.894. Go do example 5 on your own, and then I'll put the answers up for you to check.
It's fine if we do the probabilities as decimals, right? Okay.
As long as it's exact decimals. If it's not exact, then
Okay.
leave it as fractions. But yeah, this one will be exact. So remember to find mu. You're going to take x and multiply by the probability that x occurs. And you add up each one of those. So we are going to find that mu is 1.32. All right, so remember finding standard deviation. Sorry, not standard deviation. Variance first. So we're going to square x times the probability and add them up. So this looks very similar to how you find the mean, with two differences. One is that we're squaring the x value, and the other is that we will subtract the mean squared. So sigma squared equals 1.658, and that's variance, and of course standard deviation is sigma, so take the square root of that. 1.287. Okay, so expected value and mu are the same thing. So if I ask you to find expected value, I'm asking you to find mu. I'm asking to find the mean. So make sure that you understand that. So on example 6, and this is how you want to think through doing any of these bond problems or any of these like gambling problems. So you have 1,000 tickets sold at $1 each for a smart television valued at $750. What is the expected value of the gain if you purchase one ticket? So you have two values for X, and then you have a probability. Okay, so your value is either your win or your loss. If you lose, you bought one ticket, so you lose $1. If you win, you paid $1 for a ticket, but then you won a $750 TV, which means you won $749. Okay, now the probability, if I have 1,000 tickets that are being sold, only one of them is a winner. So this is 1 out of 1,000. This is 999 out of 1,000. So my expected value, or my mean, is going to be -1 times 999 over 1,000 plus 749. Oh, sorry. Times 1 out of 1,000. So then my expected value, so what expected value is, so suppose you played this game or you played this raffle, whatever, like 100 times or 500 times. Over the course of all of that, your expected value is how much you are expecting to gain or lose. So you'll win some, you'll lose some. And it is saying that you are expected to lose 25 cents over a course of playing this a lot of times. So that is what expected value is in this sense. All right, next one. So similar. So we have two bonds. You have bond X. It pays a return of 4% and has a default rate of 2%. We are investing $5,000. So I have X and P of X. So paying a return of 4% means how much money, if this investment pays off, you are expecting to make. So to find how much money you expect to make, you're going to do 5,000 times 0.04. So the best case scenario is we make money, which is that we're going to make $200 off of this. The default rate is what the chance of you losing your money is. So this is the probability that we lose all $5,000. Okay? And then obviously the probability of making that investment is 0.98. So my expected value of X is going to be $96. Now you have bond Y. Has a 2.5 return and a default rate of 1%. So investing $5,000 there. So basically you're deciding where to invest your $5,000. So again, 5,000 times 0.025 means that if my investment pays off, I make $125, but obviously I lose 5,000, but this one default rate is 0.0, so it's smaller. So my expected value of Y is going to be $73.74. So when I compare these two, I am going to say that bond X would be a better investment. Remember, on a problem like this, you have to have the math to back up your conclusion. If you just say choose bond X, you're not going to get any credit. So you actually have to have the math to back this up.